So, thank you so much for taking the time to do this interview with me today. Just to reiterate, my name is Annie, and I created Sustainability Beyond the Lab as a website to highlight sustainable research as well as the barriers to why, these promising technologies are not widespread. Could you give a brief introduction on yourself as well as your work at Stanford?
Absolutely. Thank you for having me, Annie. So yeah, my name is Thomas Jaramillo. I'm a faculty member at Stanford University, as well as at SLAC National Accelerator Laboratory. I serve on three different faculties within the Stanford SLAC ecosystem. I'm a chemical engineer by training, and I'm in the chemical engineering department. I'm also in the Stanford Doerr School for Sustainability in the energy science engineering department there. And I also have a joint appointment at SLAC via the Photon science faculty. So really within these domains, I get to operate on energy and sustainability research. I also direct a center that really crosses these bounds as well, called the SUNCAT Center for Interface Science and Catalysis. And we're really all about chemical transformations for energy and sustainability, i.e., how can we make all the molecules that we need and consume them in the proper ways so that we can get the energy that we need, the food that we need, the transportation that we desire, et cetera, to achieve all our goals and live a high quality of life. So that's a little bit of what our research is up to, developing new technologies along those lines.
Mhm. I looked on your group page and saw a lot of focus on catalysis, specifically like photocatalysis, electrocatalysis, and thermal catalysis. For maybe an audience with less of a technical background, is there any particular reason why catalysis is so important for the clean energy transition or sustainability?
Yeah, great question. So a catalyst, we might all recall, is a substance that speeds up a reaction without presumably itself being consumed. And that's really important because it turns out that for us to live a high quality of life, this is more than just sustainability, I would say. It's really just saying how we live as human beings with 8 billion people on this earth. Right. We want to be well fed. We want clean water. We want clean air. We want to be able to travel and transport ourselves and visit family and go maybe on the other side of the earth. And we want to go hiking. We want to do all kinds of things that required materials and energy. And the way that we live today, really, it's really quite remarkable. I think the human achievement of being able to develop technologies that can allow us to do all the things today that we couldn't do even 100 years ago, much less 1,000 years ago. The challenge is that a lot of the good things that we are able to do today were never designed with sustainability in mind as a design principle. And so really it's about rethinking where we want to be in the next 50 years. And in some cases, it's really developing technologies that can accomplish the same things that the current ones do, but in a sustainable manner. In other cases, it's really just leapfrogging it all together and just coming up with a better approach in the first place that not only accomplishes things better, but also in a design from scratch sustainable way. So there's a lot of opportunity for innovation in that space, and catalysts are a key component because a lot of what we need in life are molecules with different properties. It could be plastics, it could be fuels, it could be fertilizers. All of these things are things that we need to do what we do every single day. But again, almost none of that is produced in a sustainable manner. So there's all kinds of innovation to be able to make those important molecules or even better molecules in sustainable fashions.
Yeah, I think your insight on that is very interesting as well. Is there any kind of specific projects that your group is currently working on or anything unique that hasn't been done before?
Yeah, that's what we try to do every single day. I would describe it as from really from a research and development perspective, the framework I like to use is what I call the ABCs of R&D. And what I mean by that is if you take a look at the alphabet and you look at the two extremes, you've got ABC on one end, XYZ on the other. In terms of research and development, if you're on the ABC end in this metaphor, for me, this is some of the most fundamental science you can imagine. It's kind of like looking for the Higgs boson, or measuring gravitational waves across the universe when black holes collide. Extraordinary science to do these things. Really trying to understand how our world works the way that it does, why it works the way that it does. But very far from a technological implementation of something you might buy on the shelf, for
Mhm.
instance. XYZ would be R&D at an oil refinery, right? For
Yeah.
instance, or in an automotive manufacturing facility where you're using R&D to improve those scaled processes.
Mhm.
And so oftentimes in research, we're in the university context. in energy and sustainability. We're kind of in the EFG portion of that. And so in our research group, we certainly do a lot of effort in that spot, but we're trying to really extend things.
Mhm.
Oftentimes, the challenges that we face in energy and sustainability are ones where we just need new innovations, new ideas, new concepts that haven't been figured out yet, where you have to go more fundamental, closer to the ABCs. At the exact same time, if you want to get technology to scale, you can't just do some cool thing in the lab and then like throw it over a fence and hope, a
Yeah.
company picks it up and runs with it. And so the companies, their processes are typically down in the PQRS part of the alphabet. So we have a lot of letters to go between kind of the EFG sweet
Mm.
spot in an academic lab to get it to where industry can scale it. So we're also in our lab kind of extending those limits. So with broad brushstrokes, we work on a lot of different reactions, a lot of different
Yeah.
technology. But this is kind of the lens with which we're going after. Some cases we have to go more fundamental. In some cases, we have to start de-risking technology that we've already proven the concept in the lab. We've got to take it further to get it closer to a point where we can work with partners to scale it.
Mhm. Yeah, one of my themes in like my website, for example, is understanding why these promising technologies aren't being scaled up or as widespread as you think they would be. Is there any specific factors that you think are the most prominent, like scientific innovation itself, or economic or policy related, that prevent sustainable research from being scaled up?
Well, it's definitely all of the above, and that's why it's important for us, whether you're an engineer or you're studying public policy or studying economics or you're studying medicine, no matter what you're studying, and if you have aspirations of improving things to make things more sustainable, very important to be paying attention to all the other areas as well, because society doesn't work in silos. We're an integrated society. We're globally integrated. We have to have the economics match the policy, match the
Yeah.
tech, match society interests for people to adapt and to adopt. Like all of these pieces of the puzzle have to work together. So there's no one single solution, so to speak. But one thing that I really keep an eye on as an engineer, one of the things that is kind of more in my control, if you will, than some of the other aspects, is really cost. And really coming up with technology and solutions that can accomplish what you want in a sustainable manner, but designed from the scratch to really be cost effective, right? To try to avoid using, for instance, or minimize using precious metals is one classic example. In catalysis, there's a lot of really good precious metal catalysts like platinum and palladium, and they work really, really well for some reactions. How can we make catalysts that can work as well or better using non-precious metal
Yeah.
alternatives, things that are more intrinsically scalable, et cetera? So I think so that's I think one approach that we take in our lab is not just doing the science and the engineering to get the job done. You got to get the job done cost effectively. And if you can do that, that really puts you in a good position to scale, but that's not the only thing, right? That's where these other portions that you're mentioning, for instance, regulatory frameworks that are consistent with that technology. We need new business models, new models for finance to help scale technologies with investors, et cetera. We need a society that is willing to maybe change what they're doing, even if it's better, even if they know it's better. It's hard to convince people just by telling them that it's better. So how do you work within a sociological framework to help that goal get accomplished as well? So all of these things and more are important. But to answer your question, if there was one thing that we probably put more attention to that's kind of more in our control, it's how to develop cost-effective technologies from scratch.
Yeah, definitely. I love your perspective on how it's like kind of a mix of all of these different factors. Would you say that academia plays kind of a specific role from a sustainable technology succeeding in the lab to it being scaled up? Um, I've definitely heard perspectives on how academia is more towards the fundamental end.
So yeah, absolutely. Academia has played a huge role, continues to play a huge role, and will continue to play a huge role in the future. I think some of those roles are evolving, but just as a matter of fact, if you take a look at all the companies that are scaling technology of different kinds, the people who are doing that and making that happen are clearly those scientists, those engineers were educated somewhere. So universities have clearly played an
Yeah.
important role in educating that future workforce to be able to accomplish those goals. And I think now with more emphasis on sustainability and more awareness of sustainability, trying to build more of that into the educational framework so that today's students are more rapidly ready to contribute to developing those technologies ahead is clearly a role that universities play. But beyond the educational framework, certainly the R&D, referring to number one, coming up with new concepts, new ideas, new innovations that are not necessarily ready to scale the day that they are invented, but really provide a new pathway, a new avenue. But it's still a long road, again, going down the alphabet as I was kind of describing. And I
Yeah.
think that's where, as universities, it's important for us to take advantage of a lot of the academic freedoms that we have to be able to explore based on our own curiosity, what we're excited about, what we think the future could be and should be. We can leverage that freedom and flexibility to start thinking about how to start scaling things earlier than normal in typical university operations. So I've been working certainly at Stanford to really help develop entities that help faculty and students along those lines to really accelerate their ideas, not necessarily to the point where they're manufacturing, but get to
Mhm.
the point where they can leave campus with something that's more concrete and more ready to scale than they otherwise might not have been able
Yeah.
to.
And then last question, is there anything that we didn't discuss during the meeting that you think is important for general audiences to know about sustainable technologies or specifically your research in catalysis?
Absolutely. There's many directions we could take in responding to that because certainly we can't cover it all in the time
Yeah,
that we have
definitely.
today. But if I were to mention a couple of quick things, I think number one is recognizing that these are global challenges, and we oftentimes are living in the bubble of our own communities, and that's an important
Mhm.
community to be thinking about. It's also important to be thinking about other communities out there because oftentimes the innovations that we have in our head and have in our hearts sometimes it doesn't match so well with our immediate ecosystem that's surrounding us. Sometimes it might be a phenomenal match with an ecosystem that might be 100 miles away or 1,000 miles away or 10,000 miles away. So I think I would just encourage everybody to try to be as globally aware as one can to understand what the different challenges are, to get to know people and be have that open mind of getting to know different communities. I think we'll find a lot of inspiration and opportunities to do some real good that if we're not as aware, we're not as well positioned to be able to take those skills and inspiration that we have and apply them towards important things.
Yeah. Thank you again for doing this interview with me. It was very interesting to hear more about your research as well as your perspective on scaling technologies.
Thank you very much, Annie, for having me. I wish you all the best.